Good morning, students. Now we are going to learn about the nomenclature of coordination compounds. In class 11, we have learned the nomenclature of organic compounds. You know how important it is. In the same way, naming the coordination compounds according to the IUPAC nomenclature is also very important. In the CBSE examination, often this type of question being asked. There are 4 rules to be followed while naming the coordination compound. We will see the rules one by one. The first rule to be followed is whenever you are naming the simple compound or a coordination compound, first we have to name its cation and then followed by its anion. For example, if you take the complex CONH3 6 times Cl3, the counter ion is negatively charged. So the complex will carry a positive charge. Therefore, the complex, which is the cation, should be named first, then it should be followed by the name of the anion, that is counter ion. If you take the second example, K4FeCN6, counter ion is a positively charged ion. Therefore, complex will carry a negative charge. So, while you are naming this complex, the counter ion, which is a cation, should be named first, then followed by the complex anion. The second rule is that the counter ions should be named as we are naming in other ionic compounds. For example, if counter ion is Na plus ion, then it will be named as sodium. If counter ion is SO4 2 minus ions, then it will be named as sulfate. The third rule is that while naming the complex ions, ligands will be named first, then they will be followed by the central metal atom or ion. In case if I have more than one kind of ligands, then they are named in the alphabetical order. While naming the ligands, we will follow certain rules. For example, while we are naming anionic ligands, the name of the anionic ligands will end with O. For example, chloride anion, if it is acting as ligand, then that chloride anionic ligand will be named as chlorido or chloro. If nitrate anionic ligand is present, then it will be named as nitrito. If you have neutral ligands, then their common name itself is used. Here I have listed the names of some anionic ligands. Students, kindly learn these names thoroughly so it will be helpful for to name the coordination compounds correctly. This is the list of names of neutral ligands. This also you need to remember. One important thing is that if you take ammonia, its ligand name is amine and there you will have double M. If you consider didentate and polydentate ligands, they also follow the same rules as we followed for anionic and neutral ligands. If you take ethylene diamine, in the coordination compounds formula, it will be represented as En. And if you take oxalate ligand, it will be represented as OX. This ethylene diamine ligand name also will be ethylene diamine. Whereas in the case of oxalate ion, its ligand name will be oxalato. Since it is a anionic ligand, its name will end with O. And if you take ethylene diamine tetraacetate ion, its ligand name will be ethylene diamine tetraacetato since it is also an anionic ligand. The next important thing that we have to remember while naming the ligand is that if same kind of ligand is present more than one type, then we will use the Greek prefix like di, tri, tetra, etc. to indicate the number of times that the ligand is present in the coordination complex. The second thing is that in case if the name of the ligand itself is having Greek prefix like di, tri, etc. For example, if you take ethylene diamine ligand, in the name of the ligand itself, I have the Greek prefix di. Then, in such ligands, we will indicate the number of times that the ligand present in the complex using alternate prefix such as bis, tris, tetrakis, etc. The numerical prefix are not considered while alphabetizing the name of the ligands. The fourth rule to be followed while naming the coordination compound is that naming the central metal atom. After naming the ligands, we will be naming the central metal atom. In the case of cationic and neutral complexes, the central metal atom or ion will be named as its elemental name. Whereas in the case of anionic complex, the central metal atom name will end with the suffix ate. In an anionic complex, central metal atom name should end with ate. Whereas in the case of cationic complex or neutral complex, central metal atom will have its elemental name. For example, if chromium is present as central metal atom in cationic complex, then it will be named as chromium itself in its coordination compound. But when the chromium is present as central metal atom in anionic complex, its name will end with ate. So in anionic complex, the central metal atom chromium will be named as chromate. Similarly, zinc will be named in anionic complex as zincate. Iron will be named in anionic complex as ferrate. Copper will be named as cuprate. Lead will be named as plumbate. Silver will be named as argentate. Tin will be named as stannate. Gold will be named as aurate. And platinum will be named as platinate. Students, you need to remember all these names. Then only you will be in a position to name the coordination compound. Then after naming the central metal atom, you will represent the oxidation state of the metal within brackets in Roman numerals immediately after writing the name of the metal atom. Now let's have a quick recap of how to name the coordination compounds according to IUPAC nomenclature. So, before you name the coordination compound, you will find out whether your complex ion is anionic complex or cationic complex. In order to know whether it is an anionic complex or cationic complex, you will find out its counter ions. If counter ion is positive, then the complex that you have is anionic complex. If the counter ion is anion, then the complex that you have is cationic complex. Then you will remember, always you will name the cation, then you will name the anion. The second rule is that you have to name the ligands. When you name the ligands, you will write its name according to the alphabetical order. And in case if more than one time the same ligand is present in the complex, then you will use the Greek prefix di, tri, etc. Another thing you will remember, if the ligand name itself is having the Greek prefix di, tri, etc., then alternate prefix such as tris, tetrakis, etc. will be used. So after naming the ligand, you have to name the central metal atom. Then now we will follow these 4 rules and try to name this coordination compound K4FeCN6. In this complex, cation is K plus ion and the anion will be FeCN6 4 minus ion. We know for a counter ion, its name is given as given in the simple ionic compound. So K plus will be named as potassium. And if you take this anionic complex, first we have to name the ligand. Here the ligand is the cyanide ion. And you have 6 such cyanide ions as ligands. So if 6 ligands are there, then I will use the Greek prefix exa. And we know if it is anionic ligand, the name of the ligand should end with O. So I will call this cyanide as cyanidoligand. So name of the ligand with prefix will be hexacyanido. Now let's move to the name of central metal atom. Here the central metal atom is iron. In anionic complex, name of the central metal atom will end with ATE. So name of iron in anionic complex will be ferrate. Now try to find out the oxidation state of central metal atom iron. We know the formula to calculate its oxidation state. Net charge on the complex will be equal to oxidation state on the central metal atom plus number of ligands into charge on the ligand. So when you use this formula, you can find out the oxidation state on central metal atom will be equal to +2. So IUPAC name will be name of the cation first, that is potassium, followed by name of the ligand hexacyanido, then the name of the central metal atom which ends with ATE, so ferrate. Then you'll write the oxidation state of the central metal atom in Roman numerals within square bracket. Now we will try to name the second compound CONH3 4 times Cl2Cl. Here the counter ion is Cl minus ion, which is anion. So the complex will be the cationic complex CONH3 4 times Cl2 plus. And now you have 2 different types of ligands, that is NH3 and Cl minus. This NH3 ligand is present 4 times. So I will use the prefix tetra. And if you take this Cl minus ligand, it is present twice. So I will use the prefix di for it. And we know this NH3 ligand is a neutral ligand and it is named as amine. And this Cl minus ion is an anionic ligand. So its name will end with O. So it will be named as chlorido or chloro. Now we have 2 different types of ligands, that is amine and chlorido. So when you are going to write it, you have to write according to alphabetical order. So A comes before C. So we will name the amine, then you will name chlorido. So 4 times amine ligand is present. So it will be named as tetraamine. Twice chlorine ligand is there. So it will be named as dichlorido. Then after naming the ligand, you will be naming the central metal atom. Here the central metal atom is cobalt. It is an cationic complex. So the name of the central metal atom will be the name as in its elemental state. So cobalt will be named as cobalt. Then try to find out the oxidation state of cobalt based on the formula that we know. So it will be equal to +3. And anion present, here is the Cl minus ion. We know counter ion will be named as named in the ionic compound. So it will be named as chloride. So first you will write the name of the cation. That is, the complex ion will be our cation. Then you will write the name of the anion, that is chloride. So when you name the cationic complex, first comes the name of the ligand, then the name of the central metal atom along with its oxidation state in brackets. Then you leave a little space. Then you'll write the name of anionic counter ion. So IUPAC name of this complex will be tetraamine dichlorido cobalt 3 chloride. Students, check whether you can solve the example number 3. I have given more examples to name the coordination compounds based on the IUPAC nomenclature. Kindly go through the rules once again and memorize the names of the ligands and names of the central metal atom. Have a clear understanding and try to solve these questions by yourself and check the answers accordingly. I have given the anionic complexes, cationic complexes and neutral complexes separately. Please go through it and check yourself. Now you try to evaluate yourself whether you are able to name these compounds according to the IUPAC nomenclature.